Hello. Hello. Hello.
These pairs are often called key value pairs, by the way. So a dictionary is basically a collection of these key value pairs, or a data structure that can store these key value pairs so that you can retrieve the value of any of those keys quickly. And in a dictionary, you can define a few more operations. One is insert, and that would be adding a new entry to this table by saying Bob is 8, for example. Another one is delete, and that would be deleting an existing entry. For example, you might say, well, I don't want this data about Chloe anymore. When you implement a dictionary, you should be able to implement it ideally so that all of these operations take only 1 in time on average. And a hash table is a good way to do that. To build a hash table, the first thing you need is an array. So here I have an array of 8 elements, just as an example. And let's say that we want to use that array or that hash table to represent the dictionary that we saw earlier, this one. To do that, we're going to put each key value pair in one of these slots. But to do that, we need a way to decide which key value pair is going to go into which slot of this array. One way to do that would be to look at the first letter, the first character of each key, and compare it to the letter A, and compute how many characters away it is from the letter A. So for example, for this key Paul, you can look at the first letter P, convert it to the lowercase p, and compare it to the lowercase a. And in ASCII code, you'll be able to see that P is 15 characters away from A. But 15 wouldn't be an index of this array because that would be out of range. So you would need to use, for example, the mod operator, mod 8, mod of the length of the array, to get the desired range. That would be 0 to 7 inclusive. And with that method, you would get 7. So at that point, you can put this key value pair, Paul29, over here at index 7. And just like that, we can decide which index of the array we want to use for each key value pair. So Jane would be over here at index 1, Chloe would be over here, and Alex would be over here. And actually, what I showed you here is already a hash table. So basically, to construct a hash table, you need an array and a dictionary you want to represent, and a way to decide which index of the array you want to use for each key value pair. Another way to describe the same thing would be to say we need a function that turns each of these keys, whether they're strings or anything else, into an index of this array that we constructed. And we could call that function, for example, h1. And with the method that I just showed you, h1 of Paul would be 7. And this function is usually called a hash function, and that's why this whole thing is called a hash table. But this particular hash function that I just showed you might not be ideal for a few reasons. One of them is this. If you consider English names, there might be a lot of names that start with J. And if you put, for example, Josh in this dictionary or this hash table, it would try to go into the same bucket as Jane. And the same thing with Jennifer. And that would be called a collision when multiple keys would try to go into the same spot of this array. And there is a way to deal with collisions, and we're going to talk about those. But for now, you should know that we want to avoid collisions as much as possible to keep your hash table efficient. And so one way to deal with a problem like that would be to consider most of the letters or many of the letters in the given key, if not all of the letters. And one such function is called DJB2. And I'm going to put a link to some information about that in the description, just in case you're curious about it. Anyway, when you're choosing a hash function for your hash table, there are a few things that you should consider. One is that it should be fast to compute. And the other one is that it should try to avoid collisions as much as possible. And that's pretty much it when it comes to the criteria. In some textbooks, they might say your hash function should be uniformly distributed or random looking or something like that. But it's really not necessary for practical purposes. And it's not necessarily better than non-uniformly distributed functions. So if you're choosing a hash function for your hash table, you should really only consider these two criteria. And when you're choosing a hash function for security purposes, you might have other hash functions should be uniformly distributed or random looking or something like that. But it's really not necessary for practical purposes. And it's not necessarily better than non-uniformly distributed functions. So if you're choosing a hash function for your hash table, you should really only consider these two criteria. And when you're choosing a hash function for security purposes, you might have other hash functions should be uniformly distributed or random looking or something like that. But it's really not necessary for practical purposes. And it's not necessarily better than non-uniformly distributed functions. So if you're choosing a hash function for your hash table, you should really only consider these two criteria. And when you're choosing a hash function for security purposes, you might have other hash functions should be uniformly distributed or random looking or something like that. But it's really not necessary for practical purposes. And it's not necessarily better than non-uniformly distributed functions. So if you're choosing a hash function for your hash table, you should really only consider these two criteria. And when you're choosing a hash function